Hi everybody, welcome back to our freebie lectures from IP Expert. The topic for today is reflexive and dynamic access lists. So these are two special types of ACLs that one of them is used to provide access to authenticated users. This is the dynamic access list, also known as lock and key, where the reflexive access list is used to protect our internal users from external threats. So reflexive access list is going to be more of like a stateful firewall where you want to give your users the ability to connect to the external resources, but you want to protect them from external connections. Where the dynamic access list can be used whenever you want to restrict access to your network to only authenticated users. And we will first start with the topology that I will be using during this session, which is really simple. We have just three devices, routers 4, 5, and 6. We have 172.30.0/24 between 5 and 6. We have 10.110/24 between routers 4 and 5. This guy here is going to be, this is the device that I will configure with a dynamic access list and then with a reflexive access list. So this is where our policy is going to be applied. And let's start talking about a dynamic access list. So what different elements I will have to think about when I want to configure this technology? Well, I will definitely have to think about my connection that I will use to authenticate myself with the router, so it opens dynamic entries in our access list. Then the access list is going to be extended, and it is going to be configured with dynamic entries. We will talk about them in just a minute. And finally, one more thing that we will have to configure is the ADO command with the access enable host option. And this can be done either for a user or at the line level. And then the reason that we need this ADO command here is that once we authenticate successfully, we want to get disconnected from the device. And this part is going to ensure that the dynamic entries in our access list will be activated. So in our case, it's going to look like that. Router 5 is going to be configured on its FO1 with an access list 101. Apply inbound. And this access list is going to be configured with a bunch of dynamic entries. We will then, any other access is going to be blocked. So initially, no one is going to be able to connect to router 4. This guy will be our HTTP server. The sessions will be coming from 6. So this stuff is going to be initially blocked. Only when I connect to router 5 with a telnet session and authenticate successfully, this is going to open that dynamic entry, which will allow me to connect to 4 using HTTP. So this is why we need that ADO command. Because normally when you connect to the device with a telnet or SSH, for a telnet or SSH session, this is for administration, for management, and management access. And what we want to do here is that instead of trying to get to the device to manage it, we just want to activate our dynamic ACL. So this is why we need the ADO command, which tells the device when this guy authenticates to that line, drop the session, but issue the access enable host option. where access enable host once again activates our dynamic entry or dynamic entries and also changes the source from any to IP address of the connecting device, which in our case is going to be router 6. So if we take a look at this on the command line, let's first thing, let's try to telnet to router 4. Telnet 10.1.1.4 port 80. We see that we have HTTP connectivity. We don't have any access list on router 5 so far, so this is what we can connect back and forth in any direction between 4 and 6. From 6 to 4 and from 4 to 6. There are no restrictions in place. So what we will do now is that we will create an access list 101, where I will just permit OSPF so I don't lose my adjacency with 6, where I will permit telnet so I can authenticate with my router from any 1 to 172.30.05 equal 23. This is the TCP. And then we will permit, well, actually, everything else I'm going to say we will deny. Right, so let's just deny. 101, deny, IP any log. And let's say that they want to see every single packet that is denied. IP access list, log, update threshold 1. And this access list goes to FO1, IP access group 101N. So this is my access list. It says permit OSPF, permit telnet to the router, just to the router itself, and then deny everything else. So from this point on, I will obviously I'm no longer able to connect to 4 using HTTP. And this is because of that explicit deny. We see we have the matches. We only allow OSPF and telnet to the device. Okay, so what happens when I know telnet to the router? Now, actually, let's modify our line configuration slightly here. Do show round section line. Line VTY04. Let's enable local authentication and authorization. And let's create a user account. Say Cisco, password Cisco. And let's telnet to 5. Let's see what happens. So telnet to 172.30.05, Cisco. Okay, we see that I was able to connect, and I was placed at level 1, and this is a management session. So two things that we have to change in this configuration. Well, one is obviously to modify the access list, because there are no dynamic entries in this access list so far. So I need to say IP access list extended 101. And somewhere between my, well, either OSPF and telnet, or basically telnet and deny, somewhere above the deny IP any, I want to configure my dynamic entry. Let's say this is going to be sequence number 25, permit, and this will be a dynamic entry, then ACL. DYN ACL is just the name of the dynamic access list, where I want to permit TCP from anyone. The source should be any, because it will be changed, it will be replaced with IP address of the connecting device. Destination we will say is any, but this is just for HTTP. So let's take a look at this access list once again. We have a dynamic entry defined here, but this entry is now not active. If I try to telnet to 4, we see I'm still not allowed because this entry is inactive. I need to activate it with my management session. This is how dynamic access list works. You have to first telnet SSH to the device, authenticate, auto command must be issued, access enable host, and this is what's going to activate my dynamic access list. And I said that we can configure the auto command in two places. We can either do this for the user, like for the administrator, or we can designate one of the lines, maybe more than one line, where you will apply that auto command access enable option. I'm gonna do this for the user, so I will say username Cisco auto command access dash enable host, and this means that when I now telnet to the router and authenticate as Cisco, we see that first thing that happened is that it disconnected my session, so I don't have management access with this user, but it also activated that dynamic access list, and this is that entry specifically. So it replaced that any with source of 6, and then the rest is basically copy of our entry. So from that point on, I should be able to telnet to 4 over port 80, which is how I basically emulate HTTP access. And we see that the counters increase for this connection. Now, one thing that they didn't say is how long this entry will be active in the configuration. So we have 2 timeouts we can set. One is when I set the timeout with the access enable host command. I could also say timeout and specify a value in seconds. This is going to be idle timeout. Or I could also use the timeout option with my dynamic entry, and this would be an absolute value. Okay, so let's remove this option and this access list, I should say, and let's now take a look at reflexive ACLs. So what's gonna be different with reflexive access lists? Okay, so as I mentioned, this is going to be more of like a stateful firewall solution. The goal is going to be to basically protect typically our internal users from external threats. Like I want to allow them to go out, but I want to block all external connections. And the way it works is that it tracks the outgoing upper layer session information, outgoing connections. So if we go back to our topology, actually let's go back to this slide over here. So let me quickly redraw this topology here. So the way it's going to work is that the internal users will initiate a session to an external resource, and we will have an access list applied here on FO1 inbound, say out in. This access list is applied inbound, which normally blocks external access. But we will also have one more ACL applied on the same interface, say REF outbound, which is used to track the outgoing connections, like this connection. So the connection is initially allowed outbound because I assume that we have the proper entry in that REF ACL. This connection is being tracked, meaning that the upper layer session information is kept, is remembered by the device, and then when the reply comes back, it is gonna be allowed by this access list based on that tracked information. So in other words, only the packets that are part of existing session will be allowed, because once the original session goes out, it will automatically update this access list with the reflected entries, which is going to be actually the opposite of that original session. So the original session is from 4 to 6. The reflected session is going to be from 6 to 4, and also the port numbers will be swapped. So this feature uses upper layer session information. There is no connection table like with a stateful firewall. It's just an access list that is being dynamically updated to allow a return packets for the session. Okay, let's take a look at this in action. We will still use router 5 over here. So let's first try to see if I can telnet to 6. This is how we will test it. I will basically try to telnet router 6. The telnet 172.40.6. We see we have connectivity. We are going for router 5. Now when we go to 5, let's now create an access list. Out, in. This must be an extended access list where you will be able to enable reflexive entries. We will permit OSPF to keep the adjacencies. We will create entry number 50, say deny IP any logs. So we just permit OSPF. And this goes to FO1 inbound. IP access group out in inbound. Okay, so what happens when I telnet again? We should see that the return telnet traffic is dropped. The packets from 6 to 4 are dropped because there is no entry to allow them in that access list applied inbound. So the out-in access list only watches for the packets coming to the device from that FO1 interface side of the network. And I want to fix it with my reflexive access list. Okay, so I will have to modify this out-in access list. I will have to add an entry that is higher than that explicit deny. Let's say entry number 20, where I will say permit. Let's say 20 and the question mark, where I will say evaluate and specify the name of my reflexive access list. Let's say that I'm going to call my reflected entries a mirror. So once again, I permit OSPF. I say that I want to reflect the entries for the session that I track, so I can allow return packets, and then I deny everything else. This is now not active because we don't track anything at this point. So it doesn't change anything. I still don't have connectivity. I need to create a second access list, IP access list extended. REF is going to be its name, where I will say what connections I want to track. So we will track all TCP sessions, and we will have to say reflect and specify the access list name, which must match what I have configured in my inbound ACL. So it was mirror. So we now have two access lists. The out-in, which controls traffic from the outside, and REF, which is what controls traffic from the inside. REF goes outbound on FO1. Access group REF outbound. So from that point on, I will not be able to ping or connect with for UDP from 4 to 6 because of that implicit deny at the end of that access list. But I will be able to connect over TCP, and moreover, I will be tracking those sessions, and I will be adding them to the access list called mirror, where this access list will be then evaluated to allow return packets come back. Show run interface FO1. So just two access lists applied here. Out-in is applied inbound, and this is once again what controls packets coming to me. And then REF is what controls traffic going out from my internal segment. And REF is also where I say I want to track TCP sessions in this case. So telnet, we see I have connectivity. I'm coming from router 4. When I take a look at router 5, I've got the matches here, obviously. So it means that my session is tracked. And I should also see entries in the mirror access list. Because remember, what you track, it goes to the mirror ACL, which is this one. And this is exact opposite of the original session. So it says permit traffic from 6 from the telnet port to 4 to the client port. And then since this is evaluated in the access list that controls traffic from the outside, that this communication is allowed because of that entry here. So it's basically like you insert this access list and those entries from the mirror access list over here. Now note that at this point I can only connect using TCP. If I try to ping router 6, I'm not able to do this. And this is because of the fact that my Reflect REF ACL only permits TCP packets. So if I want to allow ICMP, IP Access List Extended REF, I have to explicitly permit ICMP communication, any. But this is now going to work in only one direction. Because I didn't say that I want to track ICMP sessions, return packets, ICMP echo replies, or denied by my out-in access list. So you always have to think about two directions. When I want to fix this, I have to not only say that I want to permit ICMP, like over here, but I have to say that I want to track those sessions as well. Because reflexive access list, this is not like with an established keyword, where you will only allow TCP established sessions. The reflexive access list, it can be configured for any protocol. So for TCP, UDP, ICMP, or even IP. So let's say no 20 permit, ICMP, any, reflect, and mirror is my reflexive access list. So this is REF. Mirror is now a blank. Let's just ping. And we see that the session was added for the reverse flow. And this is now evaluated by my out-in access list. This is why echoes are allowed. Okay, just to finish this short lecture, I'd like to mention about our websites, Facebook and Twitter accounts. You have them listed over here. In case you have any questions related to this session, just shoot me an email at piotrk@ipexpert.com. Thanks for watching.